Okay. Hi, good morning, everyone. Welcome back to our 2-Bit Circus Foundation live stream. Today is Wednesday, and we are doing water desalination. My name is Evelyn, and for our playful learning hour from 10 to 11, we will be doing a project called water desalination, which is a simple project, self-explanatory, right in the word. Desal means to like remove, basically salt from water. So if you can tell, like our like I think like 97% of Earth is water. Um, Correct me if I'm wrong, but I think according to NASA, it is 97% or so, 95. Is covered by water. Only 3% is roughly like considered fresh water, but only 1% is easily accessible and yeah, accessible for human consumption. The 2% is stuck in glacier and Stark on it. Thank you for joining us. Okay. But yeah, I was just giving down a quick facts about fresh water. 95% of water is made up of Earth is made up of water, and only of that 95%, 3% is considered fresh water. 2% is stuck in glaciers, icebergs, stuff like that in Antarctica, like snowy, cold places. And only 1% is considered to be fresh, is fresh water, of course, and accessible for human use. A couple of examples that are like human use would be domestic use. For example, bathing and cooking. We use water pretty much every day. I don't really water for them to grow, right? Whether they're like seasonal fruits, seasonal vegetables, they require so much water. The third one would be industrial use. For example, factories use water as well to like power on like wind turbine, hydroelect, hydroelectric dams or stuff like that. Um, yeah, welcome. If you're just tuning in, welcome to our stream from 10 to 11, a playful learning hour. Today's project is fun. We are using water, of course. If you can see here, we have salt, and simply put, our project is called water desalination. I just logged in. Is there a lag? Is there a lag? I'm not too sure. Is there a lag? Is there a lag? Yeah, I don't see myself moving. Okay. Well, we are going to fix that, but hopefully it's not lagging. Something control. But yeah. Good morning. Welcome. Good morning. Thank you. Hopefully you guys can hear me well too. I know the mic is a bit there. Okay. So we're gonna go a good ahead and start. I'm just give you a rundown of the materials that we will use today. I have here a pot, a large pot. This is a metal pot. Any saucepan really works well as long as you're able to fill up until the height of your mug. So again, I have a large pot, my mug. I have some table salt. I have some ice here, and I have water and my aluminum foil and a few wooden sticks. You can use a spoon or a stick, just something simply to stir in our solution. And we're gonna go ahead and start. So here I have my pot. I'm going to pour some water up until, like, let's say we have here, if we look inside, I know this is reversed, but each line represents 1 cup. So if I fill it up to here is 1 cup. Let me just show you this side, probably to fill like half through the mug here. So I'm gonna go ahead and pour my water here gently. Careful not to splash. I'm going to fill it up about there. So that was actually, I poured in 2 cups of water. Now I'm going to grab my table salt, and I'm For salt, I'm going to grab my stick and just stir it. The thing for this project here is you don't want the salt water to completely dissolve. So we're gonna stir, and you kind of want to hear that little sound of like the salt not dissolving completely. This is what we want. So I'm stirring, and if you can see here as well at the bottom, you can see like that little cloudiness white around here in the center. That's all our salt water. So to put into context, let's say this was the 95% of the salt water in our oceans, and we just created this solution with water and salt salt. And we're going to just stir. And we're stirring. All right. Once that is done, we are gonna put this to the side, and we're gonna grab our mug, and we're simply going to dip it into our water just like that. I consider using a mug since it is on the heavier side, and if you use like aluminum cups or let's say a plastic cup, which I do not recommend, a glass cup, make sure it is heat proof, meaning it can resist heat, or using like a coffee mug is fine as well. But yeah, because it is gonna get pretty hot. So now that I have my mug here, I have my little stove, electric stove here. So now I'm going to place this on top just like that. Before I do that, however, I missed a step. I'm going to grab my aluminum foil, and this is going to act as a cover for my, I'm going to grab this and rip it out. And I am going to kind of create this little gap, not gap, but dent in here, kind of molding it to the shape of the mug, just like that. And then we're going to just wrap it around like this. Wrap it around. And we have it covered like this. And now I'm going to grab my ice and place a few of my ice cubes in the center. Just a few ice cubes in the center. And so now it is ready to be placed on to the heat. So we're gonna leave it there for about, I would say like a few minutes. Let me make sure this is on. It is on high. And if you're doing this with the little ones, of course, we suggest parents to do this part and then turn on the heat. Have yourself place it, or the kids, however comfortable you feel letting the kids handle this part. If you can start hearing, it is gonna like kind of start boiling a little bit, but I'm gonna leave this to the side. Now there's another method of filtering out water. This is my filter that I created. Hypothetically, let's just pretend this is my water here. The white represents my water. And if you can see here at the bottom, I'm not sure if you can see right here, these black beads represent my charcoal. Oh, and it is starting to melt. Okay. And if you can start hearing it, maybe it's too far, but you can hear it boil, which is good because that's what we wanted. We're gonna wait until this boils. And basically what we're doing here is we're evaporating the water so it transforms into fresh water. So we're removing the salt from the water. Yeah. So let me just go back to my filter here. We're gonna hypothetically say that our black here represents our charcoal. There we go. Okay, the rocks. And so I've layered them like this, right? If this were to be my water, and this is just like a survival hack too as well, if you're ever like hiking and let's say you're like dying of hydration or something and you like happen to run out of water but you're near like some lakes, you can use this as a filter system. But yeah, so what it's doing here, if I were to actually have like fresh salt water poured down here, it will like kind of purify it or clean it out of the like bugs or trash and stuff, whatever was inside. So yeah, you can hear this. It is rapidly boiling, which is a good thing. That's what we want. I'm going to lower it a little bit, just like that. But yeah, thank you guys for tuning in. If you're joining me just now, this is a project that we call water desalination. So, are you going to use this? Which are you going to make it better? Oh, okay. But yeah, this project beaches are known to be saltwaters, and we have a few lakes here in the United States. I think Lake Tahoe has fresh water. Correct me if I'm wrong, but if you know any other lakes or places that have like fresh water, let me know in the comments below, because I am interested in like visiting one of these places someday. I know also Lake Michigan has fresh water. I know there's one other lake called, I am forgetting the name of it, but it is in Michigan as well. But yeah, I'm just going to read your comments. Starks on it. No. Okay. Also, another question I wanted to ask you guys. Do you think this process called water desalination is a physical or a chemical change? I remember physical change is something that changes a chemical change is something that can't be reversible. So for example, if I were to like make a cake and I have my cake mix, my eggs, my milk, my butter, and I stir it all in together, I can't, you know, take out my eggs again or have them back because they've already been mixtured. While a physical change represents something that is melting, for example here, a hint, a freezing, melting, also like boiling would be an example of a chemical change. So what do you guys think? Is this a physical change, chemical change, a combination of both? What do you guys think this is? Okay, DIY Kids commented physical change. Okay. I would say it is a combination of both. You are changing the composition. You're changing the states of matter. For example, we had liquid, right? Now we're turning it into a gas. And also to defend, one can argue that it can be considered a chemical change because you are changing the structure as well, like all of these bonds. Like for example, just to get a little bit of a chemistry background, to kind of like, you know, remove electrons and cause this whole like reaction to it. It's just a fun, yeah. Is it black? And yeah. Let me know if you guys have any questions while we're waiting for our pot to boil just a bit more. And yeah, if you can see also here, the ice is melting. If I can just bring it a little closer, you can see the ice on the top is melting, and this is acting as the process of condensation. So if I don't know if you get out the shower, you take after you take a hot or a warm shower, you can see how your windows, your bathroom mirror is a bit foggy, and that is a process of condensation. It's just like a form of evaporation here that we have. And how long does it take to boil? I would say like about a good 15 to 20 minutes. It's as if you were boiling water as well. Boil. We have our ice here. And remember, you would want to grab after we check out how the water is, we are going to grab a paper towel and just kind of like pat down the water here so it doesn't soak on us. What do you guys think if I had 2 cups of water, let's say one filled with fresh water or tap water and the other one with salt water, which one do you think would be more denser? Which one can if I were to place like let's say a potato in one of them or like some type of object inside another one, what would float? Actually, let me see if I have some cups here. I do. Can I do this with other liquids? Maybe juice. You can maybe juice. The main takeaway of this is that you can create your own fresh water, and just getting the concept of like removing salt from the water. So again, I am going to demonstrate like how different objects have different densities and stuff. What juice? What juice are salty? What juice are salty? I don't know. I don't have an answer for that. I think all juices have some sort of percentage of salt, just like a small percentage. But yeah, okay. So here's one with my fresh water, right? And my next one here is going to be salt to this. Let's see, just about that amount seems right. So let me just close it so you guys can see the difference. So I have my salt and my water is like at the bottom. Not sure if you can really tell. There's like little crystals right here. And also if you can like hold it up to the light, you can see like all these little small particles just floating around and the salt just staying at the bottom. Meanwhile, our fresh water is just clear. Like that. Maybe if we were to have like a microscope, we can go more in depth and like minimize how the water particles look like in real life. But yeah, so I'm going to stir this up. I'm gonna put this aside. And let's say we can use this as an example. Do you think my beads that I have here will sink in my salt water or float? What do you guys think? Hypothetically, just, take a guess. Okay. We're going to test them with both, which is adding a few beads here, like they're on the top. So now I'm going to go ahead and put this aside. Maybe add a little bit of more beads. So I'm going to switch now to my fresh water and let's see if the same thing happens here. So it is floating as well. I'm going to give them some time to I don't know. They are sinking at the bottom though. So let's see if over time these sink or not. Maybe you can try this with another example, like a potato, like I mentioned, comparing a potato with one that has salt water and one that has like fresh tap water. So now I'm going to check on this. I'm going to turn it off. And let's see if, again, you want to be careful because a little flap here and check out my salt water. Okay, maybe we need to, I'm not sure if you guys can see that, but there's definitely some evaporation going on here. And boiling. I think we need to leave this on for a few more minutes. There is some water right down there. You can, I don't know if you can see it. I don't want to take out the mug just yet, but we're just gonna keep it on high for a little more. And just make sure you wrap the whole bowl inside it. Make sure there aren't any like little holes. Oh, it can be hot. And be careful, it is hot. Perhaps using like some kitchen mittens would help too, or just like a rag. And I think I'm going to add a little bit more ice. Let's turn it up. And here we go. Hi, Snida. Pickle juice would be. I think they will float. So you guys think the ones with salt water will float? Pickle juice. Electrolytes. Electric stove, but using your stove at home works as well. Alternatively, you can also do this, although it will take a longer process, but there is an alternative method of doing this. This is just like the more faster way to do it, since we are applying so much heat to this. But another way to do this is if I grab, like, for example, a plastic container, fill it up with my water, salt, place your plastic wrap on the top. Your cover will have like little condensation dots. Water droplets above on inside, and you will see how like the water has been like evaporated and purified to fresh water. I'm not a fan of pickles. Midway mark, I'm just going to simply quickly recap what we've gone through just now. So this project here is water desalination. And I am using basically just water, table salt. Now I'm wondering, do you think ionized salt would be different from this table salt? Or different kind of salts react different? That's a good question. Some heat to it because you don't want to use it up. And I grabbed a mug. I put it in the center. Of course, you want your mug to be heavy because you will have tons of water surrounding your mug, which you don't want your mug to float because then it won't really, you know, be in the center and trap the water inside. Don't try this without instructions and parents. You can set up your own current yeah. Just a quick facts about, according to NASA, there's roughly 90%, the earth is covered of water. There's like roughly 90% water on earth, and most of that, well, actually only 3% of that is fresh water, and you can find those like around glaciers, found in glaciers, like I said, and 1% is easily accessible. So that's the water we have access to in our house. Industrial use water as well, and it's used for agriculture. So of course, we need food and water to survive off of. So I've noticed here that my ice melted. I'm going to bring this down, and I want to get rid of my water on the top so I can add more ice. So I'm going to go here and grab it. What about often the result of how often the results is to for more research. How will different salt impact the process? Exactly. How will different types of salt impact? Whoa, that's really hot. Okay, I am going to grab my here. I'm going to grab it and I'm just going to soak it and wet it like that. I don't want to lift the aluminum cover just yet because I want it to fully evaporate. And I think so far we've been doing this for like 10 or so minutes. The water planet. I love planet Earth. Yes. And of our body is made up of water. So it is very important to keep your body hydrated, drinking lots of water, especially during the hot days, because our water is composed of it. And if you think of it, our cells require water to kind of reproduce and form new ones. So there I have it. So now I quickly want with high concentration, water is a precious resource. It is a precious resource. Thank you for pointing that out, Deep Ocean Doctor. And I know salt water is a very like important or talked about, most frequent talked about topic in marine biology, because that's where like a marine life is, you know, hosted, and that's their like a habitat, their community. And I know there's been like so much research regarding salt water. There is a way to do it with solar, which helps, but it would take a lot of effort. Yeah, it will take a lot of effort. You're saying. All right. Oh, I forgot to turn this up, but I'm going to take a little peek at it one more time. And yep, we can see our water like dripping down our mug. So that's hot. One I just thought about was maybe instead of using, you know, a stove or applying like heat to it, maybe boiling water itself and then placing a mug inside that. How effective would that be? Okay. I'm gonna put this away. Do you guys have any questions? Maybe some want to share like some fun facts about salt water, or just water in general, like some fun facts about boiling. I know this method can be used in different like ways, not just for like drinking water, or like watering our plants too as well. Yeah, you can totally hear that boiling, and that's what we want to hear. We want to hear like rapid boiling bubbles, and yeah. So now here, remember how we had our pot with just salt water that was just like considered a liquid. It was just like table salt and water, just sodium chloride with like some H2O. That was one state. However, now transferring it back to some heat, adding heat, having that evaporate, is considered like a physical change, because we are changing the composition. We're removing salt water from this, and just don't want the ice water to flow. And yeah, you can see the steam boiling. This is like a reaction, some type of gas that you can see. And thank you guys just once again for tuning in. Thank you. Alright. is moving really quickly. I'm just going to leave this here for a few minutes. I am going to pour it down and take out the water. Because I don't want it. No! Don't want my water going through. Again, hopefully, I hope this is helpful. You can try this at home, or not even at home. Let's say you're out camping, you're stuck somewhere, you're like dying of hydration, and you happen to be near a lake. Making your own purifier. There. All I'm doing in quarantine is cooking. Nice. What are you cooking, Stark, on it? And just to give you like some like heads up, our project for next week, if you join me on Wednesday again, we will be doing a similar project like this. I've kind of done it in the past with metal etching, sort of. But yeah, so tune in for that as well if you want to know. Moving the water that has been evaporating from the ice cube from the top, because I don't want it to go to the bowl, my salt water underneath. What age did I recommend for this project? That's a good question. I would recommend it to be somewhere like between middle school, just because you're dealing with a stove. But definitely you can do it with younger kids, like let's say second grade, first grade, of course, anywhere from that up, first, second grade up. Because this is another way of teaching them like an experiment, how to separate the salt from the water. Yeah, that was a good question. DIY kids. Alright. So now here. Nice. What is it? The freezing point of water lowers as the amount of water distributed. Yes. Gin dog. Thank you for that fun fact, or that letting that know. The freezing point of water lowers as the amount of salt dissolved is increased. Yep. Okay. Let's see. Our water boiling. I am going to turn it off in a bit. Is that off? That's on. Okay. Okay, now it's off. Now it's off. And before we remove it, just let it cool down for a bit. Grab some kitchen mittens, just so you don't burn yourself, because it is you are touching metal, and you know all the heat has been surrounding this whole pot. And just be careful with taking off the foil. I'm just gonna let it cool down for a second, and just let all the steam kind of move away. Nice. And we're gonna have our water here. Are you going to drink the purified water? Am I going to drink the purified water? It says, I'll drink all this. It says 120 gallons of water for one egg. What? For one egg. So imagine how much water we're using daily to grow our crops. Are you? Let me see. Oh snap! Pickle juice. Can you tell that I'm doing? What do you recommend? The freezing point. Oh, 6,000 gallons of water is required to grow a day's food for a family of 4. Nice. Wow, that's a lot of water. Of gallons of water. About like 6,800 gallons of water required to grow a day for food. Dang, so we multiply that by like a year. Wow. Okay, I'm gonna remove the ice. I still have a little bit of water here. And applying heat to the salt water in here. Yeah, you don't want to touch anything inside here because it is hot. So just let it cool down. And I don't know if you guys can tell, but if I bring it a little closer here, surrounding the pot here, you can see all like the salt marks and the white little crystals that have been evaporated from the salt. But yeah, and you can see inside we do have some water inside it. Probably not, you can't tell, but you can see the water inside. And all these little droplets here were formed from the steam. Again, this was like from a liquid turning into steam or a gas, a state of gas. So yeah. So now let's see. I want to take out my water right here. Put this aside. Let me catch us on the comments. Are you guys thinking it takes? These facts are crazy. They are pretty crazy. I'm surprised to myself. That amount of water. Dang it! What? Wow. A jellyfish and a. They want kids. Any age kid would. I think 7. I would get a lot out of it. Yep. So here we go. Awesome. Again, it is really hot. Let me use a paper towel to just bring it out. Let me place it here. Right there. Unless you're a little close up, is this water right here. And can pour it inside a cup. But yeah. And then here inside we can see the steam, of course. This is just fogged up. Like little crystals of the salt. So if I were to do this, and you can see it. But yeah. And if you're wearing glasses, make sure kind of step away because they do fog up your glasses since you are like in very hot temperatures and steam. And this was our experiment here. Condensation. So yeah. Okay. So now there you go. You can see the little salt particles just moving around. So just to put it into context, our salt water, right? This is a majority of percentage of water that we have around in our oceans, while our salt water, I mean our fresh water. Oh, that was really hot. Our salt water, fresh water, sorry, it's kind of like a lower percentage, and advising that we take care of it because as you can tell, as presented by these numbers, it takes a lot of water to produce and grow crops and maintain our survival. I know a few tips that I do myself. Let's say when I get up in the morning, I brush my teeth. I turn off the water faucet when I'm brushing my teeth, so the other water that's running it doesn't go to waste. And it also, like, who wants to pay like a very high water bill? I don't. But that's one way. Also, I know for like shower heads, you can have like these different kind of like strains that come out of the water. So you can have like a very like high pressure to water come out, or kind of change the kind of like the amount of water that can come out, or how fast it comes out. I'm pretty sure you guys have seen that. I don't know what it's called, but I know there's like an adapter for your shower head that you can just like attach to, and it will change the water outcome. Okay, and yeah, there we have it, you guys. We have our fresh water here. I'm not sure if you can see that, but let me just zoom in. I know it's kind of hard to tell. If I had maybe had some like food coloring, I can, show you how much water is in here. But again, you can do that try it out with different types of salt. You can add some food coloring to the water. It will not change. I no, yeah, it won't change the color because you're simply just evaporating it. But if you try it with like table salt, iodized salt, Himalayan salt, different types of salt, yeah. Do you guys think there would be like some type of difference? Also, would you think adding the amount of water matters, right? The amount of water we have in our big bowl, does it matter? How much water will be evaporated into our smaller cup? Those are like some questions to think about. Um, or just some experiments to try out at home. Of course, it's all about like trial and error here. We learn there are mistakes. This project, of course, all you would need for this is just like water, some table salt, aluminum foil, a bowl, of course, some stove appearing in your cup. Various estimates indicate that based on business as 0.3 planet would be needed when you sustaining global population achieving the lifestyle. These are very, very interesting facts. Wow. And just to consider the amount of water we all use every day, for showering, cooking, cleaning as well, washing our cars, watering our plants every day. And I know California is considered like a desert. Is that right? So that means there's not a lot of water of happening this time around. So yeah, do you guys have any more questions? Or what do you guys think? I know you guys commented that this was a physical change. I would agree to some extent. However, you are free to think otherwise. The reason I think this is a physical change and a chemical change is because you are changing the substance. However, you're also changing the composition. It is still water, of course, but the molecules have formed, a different substance. Now, this is not considered salt water anymore. It is considered fresh water. However, it is a physical change because you can add salt water to the fresh water and, go on and on and on. Can I use anything else? What do you mean anything else? Like water or juice? if I don't have aluminum foil? That seems to work. Also maybe adding